In this video, I will talk about how I can make electrons, an electron that is inside a wire. This is one of the mobile electrons. How I can make this move by controlling the charges, the charge distribution that I have on the surface of the wire. And this here, this is a wire. I have plenty of mobile electrons inside. I'm just gonna draw one to give you an idea of the physical mechanism behind the current. How do we create motion of charges inside the wire? Now let's do the following. I'm gonna place one electron here, one electron there, one here, one there. Now, I'm going to think about the electric field that all of these charges on the surface generate. So, the electric field at the location of my mobile electron from this one, it's going to point from this one at that location, is going to point that way. From this electron at the location of that, it's gonna point towards this one, and the same idea here and here. Now, if you can see, when I add these four vectors, these four electric fields, I get 0. Okay? This means if you have a uniform charge distribution, if you get a uniform surface charge distribution, then your E net inside is exactly 0. Let's erase those for now. Now, if I have a net electric field of 0 inside, there is no force acting on the mobile electron. The mobile electron isn't going to go anywhere. So what I need is to change that. I'm going to put now 2 here and 2 there. And the electric fields that are created are the following. I still have the same as before from that one. I still have the same as before from that one. But now I have a stronger electric field because I doubled those pointing that way, and a stronger one pointing that way because I doubled those. If you add these 4 electric fields, now you will get a net electric field pointing to the right. I'm gonna erase these individual ones so that we can have a more clean picture. So by adding all of those electric fields, I will get an electric field that points to the right. And because this is a mobile electron, Q times E, it's an electron, it's a negative charge, the electric force on this electron will point that way. So this is the direction of the electric force. It makes sense. This mobile electron is repelled more by these ones than what it is from this side. That's why it's going to start moving to the left. So the key to having a non-zero net electric field inside your wire is to have a non-uniform charge distribution. So a non-uniform surface charge distribution will give you a non-zero net electric field inside your wire, and this is gonna make your electrons to move. That this is what's gonna give you the current in a wire. Anytime, this is important, anytime you see that there is a current flowing in a wire, this is because on the surface of that wire you have a distribution of charges that is not uniform. And that gradient, that difference on the surface charge density is what makes your charges, your current flowing in the wire. Okay, this is important. You will always have a non-uniform surface charge distribution when you have a current. Now, you can achieve, in this case, I did this example using electrons on the surface. They don't have to be electrons. You can have excess positive charges. You can achieve the same result. For example, let's say, I'm going to erase this for now. How can I use positive charges to make this electron to move? Let's make those plus, 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 plus. All right. Now, let's think about the electric field. Let's think about the electric field. The electric field from these ones, it's going to point this way, and it's going to be a long arrow pointing this way, away from those. A shorter one this way, a shorter one this way. So the net electric field at the location of the mobile electron is going to point to the left. And this means the electric force will point to the right. So I can use a non-uniform positive surface charge distribution to make a non-zero net electric field here and make my electron move. Now, if I do it this way, I'm going to make my electron move to the right because the electric force on the electrons points to the right. If I wanted the mobile electron to move to the left, I would just put, let me show you. If I wanted to have more, I would put 3 pluses here, 3 pluses there, so that I have, I make the electric field pointing to the right and the electric force to the left. I hope that makes sense. Feel free to try that and see what happens. So, at the end of the day, whether it's plus or minuses, it doesn't matter. So long as you have a non-uniform surface charge distribution on the surface of the wire, you will get a non-zero net electric field, and that will drive the current in your wire.